Okay, hey, welcome. My name is Matti Tahvonen. I work as a developer advocate in Vaadin, and Vaadin is traditionally actually a Java company. So we make Java UI library, and you can use that with Spring, for example, with Spring Boot, and it's a component-based library. So we know a lot about components in Vaadin, and lately we have been quite keen on web components and Polymer, and our next version of Vaadin framework is actually going to use Polymer-based component implementations that are used on the client side. On the server side, we are still using Java, but now that we are actually already building these new components, we have started to work a lot with like plain Polymer-based applications and practically with any client-side application, like a thin clients as well, because you can use those web components that we have built with practically any client-side technology as well alone. And the topic was today actually progressive web apps with Spring Boot and Polymer, and I think the abstract actually told that there will be like a full example application containing all these buzzwords, but because this is what I was coming to talk about, and my name is not Markus Hellberg, so actually this talk was by Markus Hellberg, who is our like a client-side Polymer developer advocate, but he couldn't make here, so I needed to rewrite this presentation yesterday because Markus thought that it would be this kind of presentation, but there was this progressive thing as well. But that's not a big deal because we have two good presentations, one about progressive web apps with Polymer and one about Spring Boot and Polymer. So I merged these presentations yesterday, and I think we will have quite a good thing about progressive web apps and Polymer apps together with Spring Boot as well. So how many of you actually know what is web component, for example? About half. What about Polymer? Does it ring a bell? And Spring Boot, I think pretty much everybody knows. I hope at least. I'm not going to spend that much time on Spring Boot, and I will talk more about progressive web applications, why they are a good thing, and about web components and Polymer, because I think there are better Spring Boot talks and which concentrate on Spring Boot alone. So let's get to progressive web applications first. Mobile web apps have a problem kind of today. This is the time that users are on average spending on their mobile devices, which they most of them that they spend on apps, not on mobile web apps or web pages. So most of the time goes on native applications, so there must be something wrong with mobile web. And what's actually better in like native applications? You can add them to your home screen. That's one good thing. And that's one way to kind of engage users to use your application. And one thing that native applications can do is also react to push notifications. So they can like register themselves and receive push notifications and do something when the message comes to this native application. They can also typically work offline, and they are most often, let's say, or always practically designed for mobile devices, unlike your web pages, which pretty, let's say, often they are either awful or they are not designed for mobile application usage at all. But mobile applications don't take the whole time, and actually I like to use often the actual web page instead of these kind of applications. How many of you have actually clicked sometimes this kind of a pop-up that some kind of a web page gives you when you search for something from the internet? You search for some answer for your question, and then there is this pop-up. It's not. This is actually not that intrusive. Sometimes they actually use JavaScript alert and say that, oh, you must go to this page and install the application. I always just say no. I want the answer, and I don't want to install the application because it's not that easy to install the application. So you need to go to the App Store, then you need to maybe find the application, then you need to give your password, at least with Apple's application store, you need to give this password, and then install it, find the application from your home screen, and then open the place, and then find the same content from that application, and then you have practically lost already. So this is really bad thing about native applications. They kind of break the linking. You cannot, if you find the answer, then you cannot share with it your friend, or then your friend needs to install the same application and he doesn't care about the application actually. Then as a developer with native applications, you need to package your application for various app stores, and then you actually, as a user, you just need to waste too much time to install the application that you probably use just once. So progressive web apps is about taking the good parts of web applications and native applications and kind of creating web applications that took the right vitamins. Like it's Alex Russell who actually coined the term progressive web apps, and it practically doesn't mean anything. It's just taking the most advanced technologies in mobile browsers and using them in your web apps and creating an application that's actually better than a native application. Google engineers and Apple engineers, I think they have some kind of a fight going on at the moment, because if you look at some presentations from Google engineers lately, they don't give kind of like any credit to Apple. And I think Apple is actually the kind of the pioneer on progressive web apps. They actually, in the first iPhone, that was the only way to make your own applications to your phone. You could give web pages, and then you could give this application manifest file, and then some other kind of extensions that Apple provided, and then you could create kind of almost like native applications with web technologies. And progressive web applications, they are these features. They provide this home screen icon, and then they should be designed so that they can work also offline, at least to some extent, and then they can send push notifications, for example. And well, this is the full list what's been defined by this Alex Russell's first original blog post. So they must be responsive, so designed for mobile devices or iPads or whatever, and they have to be connectivity independent. So practically progressive web applications, at least when you have used it once and maybe install it to your home screen, you can open that application without internet connection. It might or might not contain any relevant information without the network, but it will at least start up somehow. And this is actually related to service workers, which I will talk about a bit more. And then they are fresh, okay, so they will go to the internet if it's available. They are safe, discoverable, which means that they have this manifest file which declares the name and the icon for the application. They are re-engageable, so you can send push notifications for reactive application. You can install those and link those. So why Google engineers are talking so much about these reactive applications now is because there's a couple of new cool technologies that have appeared during the last year to mobile Chrome browser. And now if you actually use this feature, Chrome will kind of automatically detect that this is like a really like a progressive web application that you should install to the home screen. And there is kind of a heuristic in Chrome browser that sees that if you come to this web page a couple of times and you seem to be using it quite often, then it actually suggests you that you should actually install this web page as an application. Currently, you can do this manually in iPhone and in mobile Android. You can take any web page at all and put it on your home screen. But that's kind of a different. The browser doesn't suggest you these kind of applications which are not progressive. And service worker, this is one new tool. So this is practically, do you know about cache manifests, which were introduced by Apple? So probably not. So this is practically the first kind of try to create offline capable web applications. So the case manifest was a declarative listing of the resources that the application needed to cache strongly to the client side, to the device. And this approach, it kind of works, but there are some gotchas, and you cannot use it for push notifications. And it's actually quite tricky in many cases, and you need to list all the resources. Service worker, it's kind of a programmatic way to do this case manifest thing, and it's really like a much better approach in many ways. And this is kind of a thread which is running in your mobile device. It's not running all the time, but it's event-driven. So if, for example, push notification service sends your device a message, it will open this service worker and send it this message, and then it can do whatever it wants. And this is the app manifest. And this is actually kind of a new version of what Apple originally had. So this is JSON-based, but contains pretty much the same things, a bit more versatile, and kind of an improved version of what Apple did in a hurry when they introduced this first iPhone. So then, web components. So this is like a typical modern web application structure. And here is another one. And now you can guess that which one was for this application. So naturally, it was this second one. So web components is about information hiding. You don't want, if you want to have like a really reusable components, you don't want to show all its implementation details to its users. So you want to create some component, and then you want to develop it further, and then you don't want to break the application that's actually using it. You can declare kind of a public API, which is practically the element, some properties, and some JavaScript API. And then you can use these elements to compose bigger compositions. You can use web components inside other web components, and this way kind of build applications. This is like really natural thing for me as a UI developer from Java. We use Java and extend classes in Vaadin applications or Swing applications, use composition there to use different kind of UI components inside each other and compose bigger and reusable components. And web components is actually about 4 different standards. So there are custom elements, which is practically this thing that you can declare this new element type that you want to use in your HTML. Then HTML imports, because you don't want to declare this in each and every web page, so you practically need some kind of like in Java, you have import clauses. And then templates. Templates is what you use in these HTML imports, where you actually declare the kind of the inner DOM of your web components. And then shadow DOM, which kind of hides these implementation details from the rest of the application. And shadow DOM has actually existed for quite a lot of time. If you use, for example, Chrome's inspector, and then there is one checkbox which you can tick, and which allows you to show the shadow DOM of native components or something. And if you inspect the element from this kind of like a slider or dropdown, you can actually see that modern web browsers, they all implement these native components. They are not native. They actually implement them with divs and some styling. And browsers like already have had this support for shadow DOM and kind of a web components for a very long time, but now it's kind of becoming an API for web developers, so they can make their own reusable components. Browser support is actually getting pretty good, but practically you cannot still use web components as such. But luckily there is a pretty good polyfill called webcomponents.javascript, and most often you actually don't want to use this because it's big and slow. There is a light version available which contains almost all features of web components that you can use. And what is Polymer then? So we are using Polymer ourselves quite a lot, and it's a helper library to actually build these kind of web components. And it's also a collection of web components that you can use to build other web components or your own applications. So when you actually want to build applications with Polymer, the question is how. And of course, first you will probably look for some frameworks. You can use pretty much any frameworks, any JavaScript frameworks actually with web components because they are so isolated. But typically with web components and Polymer, the DOM is the actual framework. So although you can use, I will show you kind of an example in a moment where we will build like full application with only web components and Polymer and nothing else. So with DOM, we have these elements. We have the built-in elements like paragraphs and header tags and input fields, and then we have these custom elements that we will be building. Then we have a data flow. We can use attributes. For example, in input field, you have the value. And then we have the declarative format that we can use to describe the UI, and we can extend all this. And we will be building these compositions, and then we will use some mediator pattern to actually share the information between web components. Let's have a look at one small, like a really simple web component. I will not show the most simplest one, but let's look at, for example, this. So this is a web component, the whole part here. It's composed of a paragraph, and then there is one span element and an input, and when I type here, the span element kind of reflects to what we type into this input field. And what has this Polymer element it? So it practically imports Polymer first, and then because we are not using actually the default input there, we are using iron input to make some data binding things easier. So that's practically just a text field with some Polymer enhancements. And then we define the actual template, and the template is here. So this is the text part, and there we have these curly braces. I will talk about them in a minute. And then we have the input field here, and again curly braces. And then we have the actual script part. This could be, if this would be like a non-Polymer web component, we should just define everything here, but now we have this Polymer thing here, and it's much easier to actually do this thing. So practically, the interesting part here is defining properties. And owner is our only property in this simple web component, and it's of type string. And as you can see, it's bind here, and these curly braces mean that it's like a two-way binding. You could have a square brackets here as well, but then it would be like a one-way binding. And if you would be, for example, typing here into this input field, the value would not be propagated back to this element. Okay. How about like a larger applications? So you should definitely have a Polymer installed, and it has kind of an init method that you can create a project. You can actually create an element or a project, but in this case we create a project, and it's kind of like a Maven archetype for Polymer applications that creates you lots of files that you just need there practically. Then we will import some Polymer elements there, and actually we imported also some Vaadin elements that we will use in this example application. And then this is what you practically get. You get an applications tube here. There is no custom components, nothing there yet, but we will create some components by ourselves, and then use some from Vaadin elements and Polymer paper elements. So we will create a to-do application. We will have a toolbar there, practically nothing functional there, just the name of the application, then a form to edit these to-dos and add new to-dos. And then we will use Vaadin grid, which is like a HTML table with the steroids and you can use that with Polymer. And let's first create the actual form, which we will need in this to-do application HTML. And then we will import paper header, which we will use for the header part. Then we will need these fields and this form. Actually, no fields here in this part, but warning grid and the form. And then we will just create the kind of the DOM structure there that we will need. Toolbar, we can place there the actual header. We can use any HTML elements inside these things. And then we will need this form, which is not ready. We will do that in the next step. And then warning grid. And at this point, we practically have like a stub for the application. There is nothing functional yet, but we can open it and have a look at it, how it looks like. And to do this in this video, actually, we are using Polymer's like a built-in web server. But if you would be using it with Spring Boot, then you would naturally just launch up the Spring Boot application, and the Spring Boot server Tomcat there behind the scenes would kind of host the application and see how it works. If you're wondering what this host style there means, that kind of just attaches to the main element of this to-do app HTML. Now we have the server running, and then we can see how it looks like. So we have the header, we have the form, which is not there yet because it's just an empty HTML file that we have imported there, and then we have warning grid without any content there. Okay, let's then create this form, and we will again create like a new HTML, Polymer module. And we will be using different kind of components. We will use warning date picker, and then from the paper elements we will use button and an input. And then similarly as before, but now with like a much smaller components, we will compose the actual form. And again, we can style them as we like. And because this is for modern browsers only, we can use, for example, flexbox layouting, and then we can kind of stretch the actual input element there to consume the most space that is left out from the actual date picker and the checkbox that we use there. And if we reload it, we will now see kind of a pretty much full application, but no functionality. So now we need to start building these data flows. So we will need to introduce new attributes and connect them to each other. And we will start with this to-do form. And here we will need only one property, which is the actual to-do item. And we will need to define the type, which is object, practically hash map in Java, and we can define the default value, and which is just an empty to-do item. And then we make these, which we discussed with the simple thing there, this repeater component. Now we make these data bindings, both two data bindings. So if we modify this paper input element in the application, it will kind of reflect to the domain object there behind the scenes. And the OnTap listener that we defined needs a function. And the OnTap thing, that's like a Polymer specific thing. It actually kind of combines click listener and tapping with your finger. And it's like pretty technical thing. Why you could practically use on-click there as well, but then the click wouldn't be that fast on the mobile devices. And now if we click to do, we can actually see that the add to do function was fired. And we actually also created this one event, to do -added event, and we fired that as well. And we will, in the next step, we will go to this main part, and there we will use actually this event and then put that new to do item to the Vaadin grid. And Polymer is not only about like visual components. As you saw, we actually imported a local storage element there. And this is really handy tool, which we can actually use to synchronize these to-do items from the Polymer element to local storage. So local storage is always stored in the device. And when we catch this to-do added event, we will push those to-dos to both local storage and to the table. And the last step is to kind of make this web page a real application. And there we will need another, like a non-visual component from Polymer. We are using Platinum package, and there a software cache and register thing. So we practically need to just define these elements into our Polymer application, and it will automatically do this pretty complex things that relates to this service worker thing. So we practically just need to import script and define this element, and now it automatically like uses service worker. It caches all the like static things that it will need on offline. It will need some styles and all these web components that we have defined, and together with this service worker and the manifest file that we added, now this should be like a real progressive web application. And now if you go to this progressive web application or this web page many times, then the Chrome browser will finally kind of suggest that please install these applications. You seem to be using this pretty often, and then you will have a progressive web application on your mobile device. And you can see the icon there that we added, and if you click it, it will open full screen without the browser Chrome. This example is available in Vaadin-Markus GitHub repository, and it's called Polymer-PVA to-do. And as you showed, this exact application didn't use any Spring Boot, but we will get to that soon. So Polymer, these are all the modules that are in the Polymer project at the moment. There are these iron elements. These are like really core. They are not that much styled elements. Then there are these paper elements which look like material design things from Google. So they have all fancy animations and styling. And then there are lots of different kind of modules. The Platinum elements, for example, that we used, they are pretty nice to have for synchronization with the server and using for push notifications and offline like we used. And then you can use pretty much any web component elements. These are the web components that we currently have in Vaadin available for any client-side development. So we have this Vaadin grid, which is probably the largest project that we have had, and which we actually used in the example as well. Then we have combo box, then we have a set of icons, upload field, and a date picker. And of course there is more to come because we have just started this career with web components. And there is actually one commercial addition as well. So the previous ones, they were completely free, but you can actually get a charting component and pretty good looking charts, and you can use those as like a web components as well. But this one costs some money. And to get a full glimpse of what we actually provide from Vaadin, go to vaadin.com/elements. But then Spring Boot, I think I'm not going to talk that much about Spring Boot itself, but how you can actually use Spring Boot to build this kind of Polymer application. You probably know how to build this backend. So the example application that I'm going to show you and share with you is going to contain a Spring Data JPA based backend, and it's going to expose some REST services that you can use in your application. And because this is, I will skip the Spring Boot slides completely, because this is kind of a full stack example, this one. It has like a real authentication as well, and because it's completely stateless, there is no HTTP session at all. It actually contains this kind of a token authentication system. And I will show you how it works. So practically, when a user comes to the application and logins with username and password, it will go to the server and create a token. So this is not that different from an HTTP session, how it works, but it actually doesn't use HTTP session at all. And you most often probably store these tokens in a shared data store between all your server nodes. And then this token is returned to the client, and it can use this token to kind of tell to the server that, yes, I'm really who I am. And then when the server kind of passes the validation, then it actually lets the user get to the data that he's acquiring. This is probably the most interesting thing in this example application, because Markus has done like a really nice job to get all these pretty difficult build tools. How many of you hate Maven? Not that many, actually. There are some, yeah. But I will promise you, if you haven't used these JavaScript build tools, you will hate them even more. So there is like 3 different tools that you actually need with Polymer-based applications. Hopefully in the future, you actually don't need Power anymore. It might be that in next versions of NPM, they can kind of migrate these two into one. But currently, you practically need development time, JavaScript dependencies, then you need Power, and then you need gulp, because without gulp, web component applications will be slow. And Markus has integrated all these tools to actually in a Maven build. So if I'll escape from my presentation and too many IDs. And too small screen. Maven. So if we execute Maven install from this project, it will actually execute the full, lifecycle. It will actually execute the full Java build of the application, the Spring Boot stuff, and then it will also do all the things needed for the actual Polymer installation, and then it will actually also do this gulp thing, which will practically combine all these web components into one thing and compress them and remove all the development and stuff there. So it will be much faster. And then I promised to show this authentication part. So practically, we have 2 filters: authentication filter, like a login filter, and practically this will do the login phase. So if you post your username and password, it will do the authentication and save the token to the server. And then there is this authentication filter, which passes this authentication thing into security context holder. And then if we go to, for example, a user details service, this is like an expense manager thing. So we will use these tokens inside the services, and this way this REST backend is like completely stateless, so no HTTP session of any kind needed. How much time do I have? Ten minutes about. Okay. So let's go to Maven again and run this application. Okay, I will use command line. Polymer, Spring. And Maven, Spring Boot, run. Oops, some other Java process running. Kill all Java. Okay, now we have a Tomcat running, and if we look at this application, actually it was not running there, it was here. In port 5000, and we have the actual Spring Boot based application, and this one actually goes to the server. So the previous example, it only used local storage and saved the stuff there, but this one actually, when you go for your expense, you modify it and save it, it goes all the way through the REST service to your database. And if we look at how this application is built, actually I think I should use Chrome because it's a bit better. If we inspect the element here, we can see quite nice DOM structure, not that many elements. And we can see actually the whole structure with one look that, okay, we have this login page, which is not visible anymore because I had already logged in, and it remembers my login, this application in a local storage. And it was showing only this expenses page. And there we have drawer panel and the expense editor. I wish I should have a bit larger screen here. So it has a drawer panel and the expense editor, which is currently hidden. And then there is also a toast, like when we save something, it will show the notification inside this toast. And if you look into the drawer, we will have stats panel, header, and expenses list, which contains, again, some web components in the shadow root. Let's try to dig it up a bit. There. So we have the shirts field here, paper input, and the actual warning grid as well. Actually, here you can actually see how the whole application was built there as well. But I will share the URL to this application as well. You can see more how it is built, and this is kind of like a full stack application, so I really suggest to look at this. But because of this accident with Markus and me, this application actually is not progressive, but you can pretty easily kind of make this into progressive web application. Markus said that you should do it last night, but I decided to sleep. You would actually practically need to add this Platinum component to actually kind of cache the shell of this application, and then you could also maybe save the existing expenses also to a local storage and do some kind of synchronization with the Spring-based backend. And this is how it actually, the data flows go there, but we don't have time to go through this now. So what about performance of web components-based applications? If you try them out, don't be scared when you first do it, because there will be a lot of requests. This is like the unoptimized state of this Spring Boot-based Polymer application that I just showed. It has 88 requests, more than 1 megabyte to kind of transfer, and it loads too long to be like a really, really good application. You don't want to have this kind of applications for your clients, especially if you are not using it with like a really strong network. So you need to optimize Polymer applications if you want to go for production. Vulcanizing means that all the HTML imports that are used in this application are kind of combined into one import. So practically there will be only one HTTP request which gets all the component implementations. In this case, they will take these paper elements that are used and Vaadin grid, and I think there was some other Vaadin elements as well in use. And then there is lots of other different these kind of JavaScript build tools, HTML minify and uglify, which kind of pulls all the JavaScript into like a smaller thing. And then one very important thing with practically all HTML applications, always use the compression on the server. That will bring down the amount a lot. And this is the gulp task that actually takes all the elements from the Spring Boot application project and takes all these HTML imports and JavaScript files that are used and compresses them. And if you use this kind of build, so you will use a different kind of Maven profile. I can actually show you the build script because it's probably the most interesting thing here. So here we have the production profile, and now because this process takes a bit of time, you should definitely use this kind of production profile and only do these optimizations when you actually build like a production war file or, sorry, jar file. Oh, okay, and there was some other optimization tips as well. So you can actually load the first elements asynchronously. So actually, in this application, if we look into the index HTML page, which is here inside resources. Oh, sorry. Here, we don't see the element here, but we have like a script which is actually executed when after all imports are loaded. Then we will actually create the expenses application HTML element with JavaScript and just inject it to the body. This kind of gives like a snappier startup for your application. It's practically your users are still waiting, but you can use some kind of image there on the background, for example, or some CSS, so that it actually looks like it's loading faster than it really is. And after these optimizations, you can see that it actually makes sense to do this. So only 200 kilobytes now, and load time is down to 163 milliseconds, so it's much faster and easier to start. So what about production usage of Polymer or web components? The browser support is not there for all old Internet Explorers, but these polyfills, they can do pretty much the things for most browsers. And actually, for example, GitHub is using some web components there, and Google is actually planning to move YouTube for web components or Polymer-based applications. So they are going to that direction. And this is the address that you probably want to take a note. So this is the actual Spring Boot application, and I hope actually that Markus can have some time to actually make this also kind of merge these two example applications into one in a pretty soon. And this is actually duplicate stuff, so let's skip that. But there is one URL that I think you should also take a note if you haven't learned about web components and you plan to try out creating progressive web applications using Polymer, you should definitely attend to this competition that we just launched today for Vaadin in Google I/O, and you can use, of course, there are any other tools, so feel free to use Spring Boot based backend there, and great way to kind of learn how to use Polymer and improve your skills if you have already tried it. Okay, I probably cannot answer all the questions because I'm still mostly working on our framework, but I can probably answer some questions, and if there are difficult ones, I will definitely pass them to Markus. Yeah. Maybe I can repeat your question.
So the first thing, it's nice that you said that apps will die and web apps will become more used, because I also believe that, and I cannot understand the first graph that you show that only 20% of the time. But that's another story. What I was lost is to do a progressive web app. Do we have to use this framework, or it's not needed? Because I got lost there.
Yeah, so Polymer is just one kind of client-side technology that you can use to build Polymer progressive web applications. So there is like no connection between Polymer and progressive web applications. So they are completely different. So you can use plain jQuery or plain JavaScript and create progressive web applications, or then you can use these helpers that the Polymer team in Google have built, and it will make it much easier for you to build, well, any kind of client-side applications, but especially progressive web applications.
Okay,
and that's the same thing with Vaadin elements as well, which I showed you. The good thing about web components is that you are not tied to web components in the whole application. You can still use whatever thing you like to use. You can use React or AngularJS and just take this one HTML element, put the import there to the top of the HTML page, and use this one web component inside your otherwise like this client-side application, which is using some kind of framework. Yeah. Okay, any other questions? Okay, thank you.